Good morning, dear students. I am Prabha. Will handle physics subject to you. If you throw a ball in the air, there are ways to predict exactly how it will fall. But there is something that we are leaving out as forces. Why they make things accelerate. So for that, we are going to move towards a physicist. You have been probably heard of Sir Isaac Newton. With his 3 laws published in 1687 in his book, Newton underlined his understanding of motion. A lot of his ideas also were new. Today, more than 300 years later, if you want to describe the effects of forces, yeah, definitely wanted to use Newton's laws. So, children, today I am going to teach you the 3 laws of Newton's, okay? There are 3 laws: Newton's first law, Newton's second law, and Newton's third law. So now I am going to explain what is about the first law. So, for example, I can give many examples. This is actually Newton's first law is also called as law of inertia. So you should know what is meant by inertia. Inertia means lack of energy. Okay, that means don't have energy. If we have energy only, we can move from one place to another, or else we should be in the same place. So same thing is happening in this. Okay, so Newton's first law is also called as law of inertia. Okay, that means Newton's first law states that if a thing or an object remains at rest, will be at rest unless an external force is given to change its state, or else an uniform motion of a body will be in uniform motion unless an external force is given to stop the motion. For example, you have a table in your house. It is an old table. It is not used mostly by you all. Okay? So the table will be in the same place for a long period unless any one of your family member will move from that place. Isn't it? So like that, if a object is at rest, it will be remain at rest unless someone is going to move it. So or else, for another example I can give for motion is, imagine the moving bus. The moving bus will be in motion unless the driver stops the bus or gives a brake. I think you all clear about Newton's first law. So next I'm going to move towards the Newton's second law, and what it states is the net force that we called as capital F is equal to the product of the mass and its acceleration. What is meant by mass? Mass is nothing but a weight of an object. Okay? So that we called as mass in physical term, and acceleration due to gravity here is, its value is 9.8 into 9.8 meter per second square. With a simple equation, we can say capital F, that is the net total force, is equal to m into a. Here is an example for second law of motion, second law of Newton's. That is, imagine a big rock or a big stone that you cannot move from the place. Okay, and imagine a football is near to it. So totally these two objects have different masses. So for that big rock we must give greater force. For the football we can use smaller force. This is the example. So for the greater mass we have to give greater force, and smaller mass we have to give smaller force. Next, moving to the third law. It is very interesting and it is very easy to remember. That is, it states that every action has its equal and opposite reaction. In simple, action is equal to minus reaction. For example, there are many and lot of examples we can give for Newton's third law. Suppose if you are slapping a person, what will happen? Immediately he will smile or give back. Yes. surely he will give back. So for every action, there is an equal and opposite reaction. While you're swimming, what happens? Why? You are moving forward and forward. Because you are pushing the water backward, and the water which comes to the back of you will push you forward. Okay? So like this, if you are blowing the air inside the balloon, you have filled it, and if you are releasing, what will happen? The air inside the balloon will come out and pushes the balloon to the other side. Isn't it? So same way it's happening in the rocket. How the rocket moves. The rocket leaves off the fuel, that is the gases. The gases which comes out is pushing out the rocket and it moves forward. So for every action there is an equal and opposite reaction. Thank you for watching. Thank you.